And so the students, most of them are students who are working in there, which is good. They're employed, making some money, and they're also working. They get to know me. And so I get to know them. And so they see me making copies, and they're walking around there and see this math. Copies of math. And all of a sudden, a couple of them came up to me and said, "Do you teach math?" I said, "Yeah, I teach math." "Where?" I told them, "Santa Monica College, of course." I said, "Where do you go to school?" Because I knew they went to school, they were going to ask me something here. And then they went to they're at another college. And I said, "Wow, guys, you doing okay?" "Well, we're having trouble with our math, sir." I said, "Oh, you really are, huh?" "Yeah, they kept on looking at these handouts." And then the next day that I went in, I got to know them by name. Next day, there they were again working. Hi, sir. I knew they were up to something. So I make my copies, they come over to work at my copier, making copies. And they had their math books with them. They were taking like elementary algebra, but they had their books with them. So I guess they were doing homework on the break time at FedEx. So they came up to me with their math books. "Sir, could you help us with some problems here?" "Are you kidding? I'm making copies. I'm busy." "Geez, I'm not at work right now." "What do you mean? You guys having problems?" "Yes, sir, we don't know how to work some of these quadratics." They were doing quadratics in this course. I said, "Oh, wow, guys, if you can't do quadratic, you just want to drop out." They gave me this look, "Yeah, drop out. Can't do it." They knew I was just joking with them. And finally I said, "Okay, where is it? Bring your book over here." So they brought their book. I started looking at some of the exercises. So that interrupted my little making copies of it. That was an interruption, distraction. So I helped them. They said, "Oh, that's all you do?" I said, "Yeah, you just do this, and that's it. That's the answer." "Now you feel better?" "Oh, yeah." So they got their books, and we're going to walk back over to where they were working. I said, "Come here." I said, "You're going to pay for these copies. You're going to pay for these copies." He said, "How much is it, Professor?" I think for all these copies, I think it's nearly $50. I said, "Guys, I know, but it's $50. I'm expensive as a tutor. In fact, this work, I charge $400 an hour. You got $50. So they got really excited. "Oh, yeah." I said, "Yeah, you can split it up, 25 for you and 25 for the other student." "No, Professor, no." I said, "Yeah, you interrupted me making copies." I said, "Okay." They said, "Professor, could we do this?" I said, "What's that?" "Could we just let the copies be free? Could we just, your copies are free today?" I said, "Oh, you guys have an allowance of some sort where you get to make so many copies per month or whatever, since you work here, free?" I said, "Yeah, okay, I'll take the free." So today when I went in, same two, they waved at me, but they didn't come up to me. They didn't ask questions. But I think they knew, I don't know whether they used all of their allowance for the month for my copies, and they didn't have cash to pay. They said, "Oh," they just waved at me. They didn't come up to me. So that's where I get my copies. I stopped by this morning to make these copies. So I think they are happy. Now, this is going to close us down for chapter 1. Thank goodness. Guys, on one side, there are 2 more examples of a piecewise function. Okay, I've already worked through one piecewise function, my goodness. I'm not going to work through another one. I think there are a couple there, aren't there? 2 more? So you guys can practice with that. If there are questions, I can do it at 4 o'clock or whatever. Much like the one, that's not the same one I did, was it? No, these 2 are a little bit different. Okay, but you can try that based on the one I did here in class, and I think it'll be okay. If not, we will work it out. I need to jump down to, here it goes. This closes down pretty much chapter 1. Transformations. Here, this class is moving so fast, by the time you get it adjusted to the different graphs and the parent graphs and what they look like and all this and that, and I gave you a page of parent graphs in class. They're saying now have students do this. Take those parent graphs and shift them or stretch them, move move them. In other words, transform them. And then they give me a list of transformations here to follow. Now, I'm going to spend some time here. I don't think I have much difficulty on this. Seems like, hang on, let me see if I did something with this. Did you guys have on the back this right here? Did I give you a grid? I did, didn't I? Yeah. So this is where we're going to close down chapter 1. Transformations. Now I need, since I'm standing here and I'm going to do some writing, I think these markers are much better now. I need a student to help me. Let me get this set up. Transforming a graph. Transformations. Different ways to do different things. Are they going to ask me to shift the graph up, shift it down, shift it to the left, shift it to the right, stretch it, flip it over, upside down. We'll see what's happening here. So I need some rules to follow. Can I have a student to please tell me what did I list for number 1? And then we'll try to make some sense of it as the first transformation that could be used on a graph. Who would like to read for me as I stand here? Got you. Read for me, please.
To graph y equals f of x plus c, shift the graph of y equals f of x upward c units.
Okay, hang on. So you're saying if it looks like this, there's my function, f of x again, could be one of those parent functions, and all of a sudden they want you to do something to it, and they're saying add to it, and they call it c. Did they put a restriction on c?
C must be greater than 0.
Okay, c must be greater than 0, a positive number. And he's telling me this is identified as what, a vertical shift?
It says shift upward.
Okay, let's call it a vertical shift up. This will have my graph to be vertically shifted up so many units. Guys, you can't go wrong with these. Example, right quickly. Remind me, did I give examples also on the handout or not? Oh, I've got on the back, but let me do a simple one here. If you saw this, I'm sure every student in class would say, Professor, if I saw this and you asked me to graph it based on what he just read, I'd take the parent graph, which is on one of the handouts, which is a parabola, and vertically shift it up forward. And that's all they want. So if I do that, I'm patient, that's all we need here. You guys can see what this graph would look like. Try to get this chapter 1 finished up here. Now, I am going to place on here first, if you don't mind, just for a little reminder. I should use this. Here's the parent graph. You saw that earlier. That's the graph for x squared. Now, to get the graph here, it says vertically shifted up as you read it to me. Shift that graph up 4. You say, Professor, really? I'm just doing this. I'm taking it up 4. Right here. And have my graph now, let's see if this marker will work for me, doing this. And I'm done. You say, oh, Professor, please place a lot of these on the exam. I'm done. I vertically shifted up 4. We're done. Now I'll tell you what the next one is.
To graph y equals f of x minus c, shift the graph of y equals f of x downward.
Okay, now hang on, I'll put it right here. So if I see f of x subtract c, and c again is greater than 0, you're telling me this is described as a vertical shift down. I think you're telling me it is. Guys, if I use that same parent graph, which it is, and now say vertically shift it down 4, let's try right here, guys. I'm going to put it right here. F of x is equal to, this time he wants x squared subtract 4 on the end. Take that red graph, vertically shift it down 4. This time we're going down. And of course the graph in this case would look something like this. Shifted down 4. Would we agree with that? Is that x squared subtract 4? quick vertical shift down for you. Can't go wrong in transformations until we get through all this and I have a problem for you. Okay, read the next transformation.
Horizontal shift.
There you go.
To graph y equals x plus c,
Oh, hold on, x plus c inside.
where c is greater than 0.
C's gonna be greater than 0.
Shift the graph of y equals f of x to the left c units.
So there's gonna be a horizontal shift, we'll call it horizontal, not vertical. And just say which direction?
Left.
To the left. Yeah, you've got to be very careful about these rules to follow here. Many students will say x plus c, professor, since I see a plus, I might want to shift it to the right. They're saying no, if I see a plus, you're going to shift it to the left. Then we'll have a student to try to tell me why that might be true, but we'll do that. He's telling me now for this one, guys, I'll come up with one right quickly right here. Yes, y is equal to, or f of x is equal to, that's it, looks like this, x plus 3 squared. Yeah, f of x plus c. Let's say it looks like that. And then we'll just sketch it fairly quickly. Well, I still have the same paragraph. I see an x squared. So that is still going on. And I like to place the parent graph on here to show it's still there. Something like that. Now, if I go with what he says here, guys, I see an x plus 3. What should I do with that red graph to get the graph now that should represent a horizontal shift to the left? Okay, and in this case, to the left, 3 units. So please tell me, are they telling me just do this, move it over 3 to the left, here, and let's try this. It might look something like this or not, we'll see. Might look something like that. Horizontally shifted 3 to the left. Is that true? Mm-hmm. That's done. Now tell me the other, then I'm gonna have that a student answer the question for us. That was horizontal shift to the left. What was the other one?
To graph y equals f x minus c.
Okay, hang on now. F of x minus c.
C is greater than 0.
Okay.
Shift the graph of y f of x to the right c units.
So this is a horizontal shift to the right. Got to get through these transformations. Okay. Let's try one. We'll try f of x is equal to show a horizontal shift to the right based on what he gave me. And we'll try this. F of x is equal to, let's try x subtract 3 squared. He says put a minus sign this time in there. And if that happens, based on what I see on the handout, I'm supposed to have on the parent graph shifted this time to the right. Let me get all this straight here. Guys, just put the parent graph, then show that. Gotta get through these basic ones, and I'm gonna show you a harder transformation to do to finish this up. Okay, the parent graph, still parabola. X subtract 3, he says horizontal shift that graph to the right, in this case 3 units. Let's see if you guys will agree. Are you kidding me? All they want then, I guess, is a graph that looks something like this over here. Do you guys agree? Can't go wrong on this until, surely, these are the basics. Wow. Now, is there another rule there to follow? Oh, whoa. Number 3. What's number 3 asking?
3 is reflecting graph.
Oh, reflecting, not shifting. And what did they say about reflecting?
To graph y equals minus f of x.
Minus out front, f of x.
Reflect the graph of y equals f of x in the x-axis.
Oh, so if I say a minus sign out front that says if you're gonna graph this, you better do this. Reflect the graph, I think you said about, I'm gonna call it through the x-axis. Now that was a little different. Minus sign stuck out front, he says that's something called reflection. So guys, I'm using again x squared for my example here, so he's telling me if I were to sketch this, a negative sign out front, then x squared, which makes it look like that, go to your parent graph and reflect it through the x-axis. Now what on earth does that mean? We're gonna find out. Here we go. And I know this looks very basic right now, and it's going to happen. It'll help us later on. The graph again, basic parabola. Now, can anyone tell me what does that mean to take that basic parent graph and this time reflect it through the x-axis? What does that mean?
It means that it just flips over.
Thank you. It's upside down, flipped over. In other words, she described that perfectly. She said, Professor, just flip that graph over, and it's going to look something like this. If this marker will hold it up for me. Flipped over, something like this. Can you guys see that? Marker's almost gone here. That's just a reflection through, just flipped over, as she described it, flipped over the x-axis. It's done. What was the next one?
To graph y equals f of negative x.
Now, this is a tough one.
Reflect the graph of y equals f of x on the y-axis.
Now, reflect this one, if I see it, through, you tell me this time what, the y-axis?
Yeah.
Uh-oh. Okay. Now, to save me a little time, let's go back and let's use this grid here. You know what this one represents. So I don't have to draw another separate grid. There's my parent graph. This time I'm going to take that parent graph, and in this case it's a parabola. And he's telling me, Professor, this time, if you're asked to graph this, the negative sign's inside this time, not out front. Like this one's out front. No, it's inside. That should be a reflection through the y-axis. Can anyone tell me what would happen if I try to take that red graph and reflect it through the y-axis? Samantha?
It'd be the same.
In this case, it's the same. In other words, what she's telling me to do is, Professor, you take this red graph and you take this side over here across the y-axis and this side over here, just from side to side along the y-axis. She says for this particular graph, you get the same answer. Now, does that happen on all graphs? I wish it did. No. But that's what we're supposed to do, reflect through the y-axis, if I see that happening. Now, it might be almost time for me to quit and get a break here. What else was there?
The last one is horizontal stretching and shrinking.
Whoa, 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 whoa. Oh. I got just a couple minutes. Now, before I do that last one, the horizontal is what, stretching in? Oh, boy. Okay, guys, I think we followed this pretty well, but the task is, when I get back, or you get back from the break, is can you, look at this, can you put all of these together, or as many as I can put into a function, and show me many of these transformations on one problem? That's the issue coming up. Like, here we go. Like, you gave me this. Let's see if this marker will work for me. F of x, much better, equals negative square root. Now, look at it carefully. X subtract 4 plus 6. We're going to see that after the break. I'm going to hold on for that horizontal stretching, was it, until after the break. So guys, after break, we'll see one where you have to apply all these transformations. Now, I'm not gonna do it right now, we're gonna take a break. Anyone tell me what would serve as my parent graph? Go for it.
Radical X.
Radical x, the square root graph. So your parent graph, and I always ask my students to place the parent graph. I said, wait, Professor, I saw that on a handout. Of course you did. Looks something like that. That's the square root graph. That's your parent. And what are you going to do to that parent? It says do this. I'm going to go from left to right. Some professors do it differently. This says to do probably to do this. Which means do what? Reflect it through the x-axis. So what's that going to do to the graph right now?
Flip it over.
It's going to flip it over, as described to me earlier. Sophia, I think you did. This flips over. Having luck with the markers today. This flipped over, and it may look something like that. That would take care of that. Now, what might the x subtract 4? Somewhere in here, right here. Tell me. Go for it.
You move it 4 to the right?
Yeah, you want to horizontally shift it 4 to the right. You got to follow all those rules there. So you say, wait, Professor, what do you mean? Well, you got now, show me this. Let me mark it. These markers will hold up 4, and let me try this color if it'll work for me. Am I now looking at, all right, hang on. Right, we get started on this. Yeah. That's a break up here. Here we go. I hope you guys can see this. This is 4 here. There you go. And looks like it might be doing something like that. See if you guys agree. Is that 4 to the right?
Okay.
Now, am I finished? Plus 6, which I think through all this routine probably means, where on earth was it? Back here. Yeah, vertically shifted up, what, 6?
Mm-hmm.
Now, we're going to get a break. We're up 6. Use that blue marker, as you can see that. And if I take this green graph, shift it up 6, I know and you know, it's going to look something like this. Would you guys agree? Right there. Is that the green vertically shifted up, even where I'm standing here, up 6? Yes? No? Would that be possible if I take the green graph up 6 vertically? Would that be for a rough sketch what it may look like? I would think so, right? I exaggerate so you can see it, but has it been vertically shifted up 6? Okay, now here's, before we close down, I've been bragging on you guys already. If that's the graph, and I think it is, shifted up 6. I think this right here would serve as a rough sketch of, look at this, you see this blue? If this blue is correct, that's the graph of, where was it, Micah? Oh, right in front of me. It's the graph of all this. We finally got it through by pieces, by transformations. We finally got to the blue piece. The blue piece represents the graph of all this. Now, can someone tell me, before we close down and take a break, does that blue piece, if it's correct, does it have an x-intercept? Now, maybe let's make this up quick. Does it cross the x-axis?
Yeah.
Now, I'd like to know where. Where does it cross the x-axis? In other words, where is the x-intercept? I know it's right there somewhere. Can anyone tell me a nice little routine to follow to find exactly where is that x-intercept located? It may not be a nice number, but there's one there somewhere. Samantha,
You can equal the function to 0.
take this function. She says, Professor, take the function. I hope we don't have a mistake in that. And set it equal to 0. Because if you're on the x-axis, you're at 0. So set your function equal to 0 and solve it. Now guys, that means you're into a square root problem, like something like on the first exam. And then I would isolate that, lots of ways to do it. You can do this. Move the 6 over. Even better, multiply or divide by the negative. Make it look even better. Simplify. And then do what to it? Square it. We've seen these before. How math comes back to us. So you're going to end up with x subtract 4 is equal to, what is that, 36? Yes or no? X is equal to, are you kidding? That's supposed to be out to 40. That's supposed to be representing 40 for the x-intercept, if we did the math correctly. Is there a y-intercept on that final graph? Look at the final graph. Is there a y-intercept? Does it touch the y-axis, which is over here? Does it touch the y-axis at all? Thank goodness it does not. I don't have to worry about a y-intercept. I have an x-intercept at all places 40. So guys, if you don't mind, squeeze 40 in there so you can see it. That's supposed to be 40. Now, here's the last question. Whew. Oh, but two parts to it. Can anyone tell me if that blue graph on the end is the correct graph? Can anyone tell me its domain? What's the domain on the final graph, if that's graphed correctly? From left to right. Go for it.
I was thinking that would be 40 to infinity.
Not 40. Is it?
Oh,
That's the x-intercept. Is it 4? Okay,
no,
is
like
4?
it starts at 0, right?
Okay, right here, yeah, starts right here. Was it at 4 guys here? I mean, I have these lined up perfectly. 4 through what? Infinity. Now, and we're going to take a break here. Range. Now describe the up and down if this graph is correct. Is it dropping down forever? That's a negative infinity. How high up does it go? 6. Including 6. Now what have you discovered? You've discovered the domain and range of this black function. That's its domain and range. Now before we go to the break, it says you gotta stay to the right of 4 for the x. I do? Okay. Gotta stay to the right of 4 through infinity. What happens if I try to replace x by a number to the left of 4? Like a 3. What's wrong with 3? Yeah, if I put a 3 in here, what's 3 subtract 4? -1. Is there a square root on a negative? No.
No.
That's why the graph says you gotta start with 4 through infinity. Those other numbers were not fit. And the graph shows me. Mathematics. Guys, take your well-deserved 10-minute break. I'll see you.